Okay, so we're back on the demo bench where I accidentally arced myself. The 4 batteries that are currently being charged are set with this grouping. They're placed on these aluminium plates, which are showing the rough size of the placement that we're going to put them in. So we're saving about 20% of the room from the original lead acids, and we're going to 400 amps. So these are banked into 4 parallels and 16 in series. So that's why they're being charged in that particular way. So here we're just doing a basic setup of what it looks like in the vehicle. So I've measured it out, put the plates where they need to go. So I've got the contactor in here for the economizer, so it might save a bit of power there. We've got the main battery pack switch cut off, which is rated 48 volts, 350 amps, and the fuse is 250, so that should be good. And that's just when you're servicing and maintaining the battery, we can, shut the pack off. I'm planning to put this in the mid section, so there shouldn't be any issues with that because there doesn't seem to be any inrush current prevention. Then we've got the hardcore shunt, which I'll show you there. So that shunts through the hardcore, so the negative side of the battery, whichever one, you actually can't read it from here. Then negative side of the battery, then the negative connect through, so you're measuring through this point, which the positive goes to, and you connect to this point, measuring all the current and everything else that your motor and battery are consuming. And then obviously you've got the 150 amp nominal daily BMS, which is 16S, so 48 volt. Charge current of 75 amp, we've only got about 35 on the maximum from the 240 volt input. Which would be fitting a caravan style plug on the side of the vehicle where you just literally plug in an extension cord, not this cord hanging out like it was originally. So here you've got a full pack on this side. There's a gap in the back here, which I intend to either place that into the box system that they're going into, or place it on the aluminium plate which you can't see during the battery pack to be mounted horizontally. But everything will mount to this and connect together with copper bars, so the only cables will be connecting the the battery pack to the positive and the battery pack to the negative. Everything else will be run with copper or bus bars. So heatsink, the aluminium gives a bit of a heat sink as well. Having so many things on there that can get hot is possibly not the best plan, so some of them might move around. There's all these CAD systems and all that sort of stuff, but I've basically been drawing everything with a pencil, a tape measure, and a piece of paper. I've got a whole section in this book dedicated to this build, so when I need to replicate it again, I'll be able to. So here's all the cells, minus the 4 over there, being charged, and also minus the 4 that were for the 12 volt system, which has its own BMS. These will soon be linked up. As I said, 4 in parallel, 16S, so we can get around with only using one BMS and not having to parallel 2 BMSs, which would be the normal for this sort of pack, or 48 volts. One of the issues we couldn't go for a Giants battery is because they don't believe they can be paralleled, because they run a different BMS. So this is the way we decided to go. That's why the battery's being charged with 4, very slowly, very low current. So they're all equally matched. Going to do a resistance test on each cell, then match the cells to the resistance. So if this one's 7 milliamp resistance, and this one's 6, and this one's 4, and this one's 9, but this one's also 7. I'll put those two together in a pack. I'll start my pack with 7 milliamp, so they'll do it written on the side as they get built together. Just on the, so this is a little Renology oven Shaw. I've not used this product before, but it's going to be running a 200 watt solar panel, 36 open voltage, that'll be mounted to the roof, which will be charging this pack with whatever current and power it can come through, which won't be very much, but if you're spending all day out working in the sun, might as well be gaining some energy from it. Also the 12 volt will be hooked up to another solar panel just through a normal MPPT controller going into the BMS. So the BMS comes with a lot of obviously accessories and wires, etc. A battery monitor, which I won't be mounting because we've got the hardcore monitor, but it could be mounted inside the battery box to have a look at things and see how we go. Also, we've got a 48 volt solar charge controller that we mounted to a garage being built by the owner with 4, 6 or 8 solar panels plug into it, so when he, at the end of the day, when he rides up on the vehicle, he just basically plugs in an Anderson plug to the side of the vehicle, and that will be charging directly off solar, and then run the output of the inverter to whatever he needs to power, if that's the way he wants to go, and it becomes a home battery, depending on which way we're looking at it. So that's a bit of an introduction to the next phase of the EV upgrade and lithium conversion. Thanks for watching.